On these last couple of problems, we're going to need some special rules for logarithms. Okay, and what you'll notice is they'll match up with a lot of the rules we had for exponents. Why? Because exponents and logarithms are inverses. They should have very similar properties. So remember when we had exponents, what did we do when we were multiplying? We added exponents. Same kind of idea in reverse here is when we have a logarithm of a specific base, we can split up the said logarithm into two logarithms with the same base. So what happens is multiplication will break up into two different logs with addition in the middle. So before we had multiplication coming together as adding exponents, now we're having multiplication break up into addition of two logs. The next one's kind of the exact reverse of what we've got here. We've got one log breaking up again into two logs with the same base, but we have division breaking down into subtraction. Notice, whatever was actually being divided by that was on the bottom is actually what's going to be after your minus sign here. Last one here that is probably something completely new is if you have a log base A, you can leave it as a log base A, and what will happen is any exponents inside of your log can just get moved out in front of your log. So notice it just can move out in front. The last rule is very specific, and it goes along with, remember when we had exponential properties, we said anything raised to the zero was 1. Well, because these are inverses, we're going to have the exact opposite. So that meant that all exponentials went through this point of 0, 1. That means for logs, we're going to have the reverse because they're inverses. We're going to have that all logs go through the point 1, 0. What this means is if you plug 1 into any log, you'll always get out a 0. It doesn't matter what the base is. Just like with exponentials, it didn't matter what the base was. Anything raised to the 0 was 1. Now any log base of 1 is going to be 0. That's going to be the hard one to remember. So let's take a look at using these rules for logarithms. So on A, we've got a log base 4 of 6 over 7, and we're going to expand this and break it apart. So because we have a log base 4, I can only break this up into two log base 4s. The first one will be of whatever's on the top, which is the 6, and whatever's on the bottom will go second, the 7. Now, because it's division inside of that log, we're actually going to break that apart as two separate logs that are subtracted. That's it. And you're done. You can't do anything beyond that. That's all they wanted you to do. So our final answer is that you can rewrite it as log base 4 of 6 minus log base 4 of 7. Let's look at problem B. In problem B, let's see what we have. We have a log base 3. So when we break this up into its two parts, we can break it up into two log base 3s. The first one will be of our first part, which is the 4, and the second part will be of the P. The question is, what's going to go in between those two? Well, what are you doing to the 4 and the P here? Originally, they were multiplying. So when you break them up, you're going to add. So what our final answer is log 2's. Now notice I've got two pieces though. I've got an x to the 5th and a z cubed. Well, if I take my x to the 5th first, well, That'll be my first piece. And then I'll put my z to the third, second. Well, what you're not seeing in between those two pieces is we've got an x to the fifth times a z to the third. So when you break that up, it's going to break up as addition. Now, we learned that there is one more thing you can do here. Whenever you have exponents inside of your logs, this was the third rule, is that you can take those exponents and just move them out in front of your logs. So what that means our logs will turn into is, the first one will turn into 5 log base 2 of x, just moving that 5 out in front, plus 3, again, we just moved the 3 out in front of the log, base 2 of z. That's our final answer. Continuing along with problem D, we don't have any rules for roots. So the question is, can we rewrite the root? And we've learned recently that you can. Remember that the root can go on the fractional exponent on the denominator. This means that the cube root can be rewritten as m to the 5/3, where the root 3 is on the denominator. We haven't done anything with the log yet, so we'll leave that as a log base p. But then remember the rule we actually just used, that any exponents can be moved out in front of our logs. So that means that this log would turn into the 5/3 that was with the exponent out in front, log base p of just an m, because the 5/3, the exponent just moved out in front. Now let's look at E. In E we have log base 6 of 7m plus 3q. Notice the one thing that we see in this one inside of that log that we have not seen yet is this plus sign. We have rules for multiplication, we have rules for division, we have rules for exponents or powers, but we do not have a rule for a plus or a minus inside of a log. So guess what? There's nothing we can do with this one. We have to leave it as is because there's no rule for a plus or a minus inside of a log. So we have to leave it as log base 6 of 7m plus 3q. There's nothing we can do with this. Now, let's look at F. On F, we have, we have division inside of our log. That division can be broken up. Okay, so what we'll start out with is we've got log, L-O-G, it's a hidden base of 10, but we'll have a log base 10 of 1 first. And then we'll have our minus sign because we are dividing by. Well, what are we dividing by? We're dividing by actually 2 things. We're dividing by the 5, and we're dividing by the p. So because both of those are under the division symbol, we're going to subtract both of those logs. So we've got a log of, well, what are the 2 things that we're dividing by on the bottom? Well, the first thing that we divided by on the bottom was the 5. The second thing that we divided by on the bottom was the p. Okay, so we end up with 3 pieces. The regular piece of what was on top and minuses on the 2 pieces that we were dividing by, because division breaks down into having a minus sign. And we're almost done. There's only one thing that we could do, and it's something subtle. It's this first piece. It's something that's really hard to remember. It's that log with any base of 1 is always going to end up being equal to 0. So this whole piece will just vanish. So our final answer is just everything else. It's negative log of 5 minus log of p. And that's it. That is our final answer. Negative log 5 minus log p.